Carnegie Institution for Science audio press release for January 20th, 2015. Caught in the Act. Cosmic Radio Burst. Fast radio bursts are quick, bright flashes of radio waves from an unknown source in space. They're a mysterious phenomenon that lasts only a few milliseconds, and until now they've not been observed in real time. An international team of astronomers, including 3 from the Carnegie Observatories, has for the first time observed a fast radio burst happening live. Their work is published in monthly notices of the Royal Astronomical Society. There's a great deal of scientific interest in fast radio bursts, particularly in uncovering their origin. Carnegie Observatories acting director John Mulcahy notes that these events are one of the biggest mysteries in the universe. Until now, astronomers were not able to catch one of these events in the act. Only 7 fast radio bursts have previously been discovered since the first one found in 2007. All were found retroactively by combing through data from the Parkes Radio Telescope in eastern Australia and the Arecibo Telescope in Puerto Rico. Emily Petroff is a PhD candidate from Swinburne University of Technology in Melbourne, Australia, and lead author of the publication. She explains that these bursts were generally discovered weeks or months or even more than a decade after they happened. Her team was the first to catch one in real time. Swinburne is a member institution of the ARC Center of Excellence for All-Sky Astrophysics. In order to observe the fast radio bursts in real time, the team mobilized 12 telescopes around the world and in space, including Carnegie's Magellan and Swope telescopes. Each telescope followed up on the original burst observation at different wavelengths. Measurements of the interaction between previously detected fast radio burst flashes and the free electrons their signals encountered in space as they traveled to reach us had previously indicated that the burst likely originated far outside of our galaxy, but the idea was controversial. The team's data indicates that the burst originated up to 5.5 billion light-years away. This means that the sources of these bursts are extremely bright and could perhaps be used as a cosmological tool for measuring and understanding our universe once we come to understand them better. Carnegie's Mansley Castlebaugh was on the team along with Mulcahy and colleague Yu Shin. She says that together, these observations allowed the team to rule out some of the previously proposed sources for the burst, including nearby supernovas. Short gamma-ray bursts are still a possibility, as are distant magnetic neutron stars called magnetars, but not long gamma-ray bursts. Gamma-ray bursts are high-energy explosions that form some of the brightest celestial events. Long bursts can signify energy release during a supernova and are followed by an afterglow, which emits lower wavelength radiation than the original explosion. Another interesting piece of information the team was able to gather about the burst is its polarization. The orientation of the radio waves indicates that the burst likely originated near or passed through a magnetic field, information that can help narrow down potential sources going forward. Mulcahy explains that as we continue to search for the source of fast radio burst, Carnegie is well positioned to make big strides in the field. Quick access to big telescopes like Magellan may be the key to solving this mystery. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.